Welcome to Ask and Learn.
So in this question, we have a capacitor. And this capacitor, it has a capacitance of 70 microfarad. And then we have a lot of charge, Q, negative Q, negative Q, negative Q. It takes, how much does it take? It takes 18.5 joules G to move 13 microcoulomb charge from this plate to this plate. Okay, so it's easy to misunderstand this question. What you are moving, the 13 microcoulomb charge, it's not a point charge you're moving in this electric field. It's amount of charge on the plane that you're moving. So it's not a simple linear process, because as you are moving the 13 microcoulombs of charge, the amount of charge on one plane and the amount of charge on the other plane is actually changing. And because of that, you can't assume like a constant electric field between the two planes. So what we are trying to do is we are actually looking at this formula, U equals 1/2 Q squared C. So we're actually calculating the difference if we have Q plus delta Q squared over C. This happens with the charge difference and the energy stored in this whole without the difference. And that gives us Q squared Q plus delta Q squared minus Q squared. And that is delta Q over 2C times 2Q plus Q. Okay, so with this formula, we can now figure out the amount of charge Q equals C times change of potential in this whole system, which is joule, over the change, which is 13 minus 1/2 delta Q. So that is 17.0 times 10 to the negative 6 times 18.5 joule over 13.0 times 10 to the negative 3 coulomb, and still we have to minus 1 times 13 times 10 to the negative 3 coulomb. Okay, and together that gives us 17 times 7 times 10 to the negative 3, which is 7.7 millicoulomb. That is the amount of charge on each plane. So again, why, as I already said, why is this so complicated? Why can't we just do work equals, like, why can't we just do work equals Q times C, and then we use that to find, and then we can do Q times C times V and use that to do. Actually, a lot of people had and the problem is that, as I said, it's not like a separate charge you are moving one plane to another plane. It's a charge on the plane you are moving. As you move, a lot of things, well, it's not, as you move it, the electric field is going to change. Doesn't change, but like, because the electric field changes, you can't just use this. You have to actually look at total potential energy before and after, and you have to actually subtract them to tell you how much work you have done, instead of directly finding like how much work it is. So yeah, so that's one thing that a lot of people got wrong. So this is a correct way of solving it.